Hello everyone. So this is the video in which we are going to solve the problem what you see on the screen right now. This problem looks very quiet, almost harmless. A polynomial of degree 2024 is given to you and there's no formula for the polynomial is given. There no coefficients are given rather. Just values, and those values are simple ones decided by a rule. At each integer, the polynomial provides k divided by k plus 1. And it provides again and again, all the way up to 2025. What I believe, this is not a problem about calculation. It's a question about consistency. When a polynomial of this type follow a pattern at so many points, it starts revealing its true nature. And when we finally ask for P 2026, we are not guessing the answer anymore. We are extending a story that has been told previously. So we'll solve this problem slowly, but by understanding each and every step. So before you jump to the solution, I request you to try this question by your own. And if you solve the question correctly, you must get the answer. So this is a time to pause the video and give an attempt to this question. And I wish you will do it correctly. Let's dive in. All right, so let's start doing this question. So we have a polynomial given px, which has the degree 2024. And the polynomial has such kind of property, which is decided by this pk by k, pk is equal to k by k plus 1. It doesn't mean it is the value of polynomial at each and every x. It is simply giving you the idea that the polynomial is exhibiting this property at only these integers. We don't know about 2026 what will happen, whether it will follow the same pattern or not. If it will follow the same pattern, we will reveal it, means we will solve it and it will be revealed by itself. It means we have to find out the polynomial formula at the first place. So for that, what we do, we notice one thing, that the pk is k by k plus 1 for integers. So by just seeing this pattern, I'm actually assuming a new polynomial which embeds this px in itself. So I'm assuming, and I'm going very slow. If you feel that the solution or the explanation is very slow, you can increase the speed of the video. Anyway, so let's do this, assuming qx is x plus 1 into px minus x. I've assumed this polynomial, and you will learn eventually that why we have assumed like this. Let's see. So suppose I want to find out the values of the qx at these integers, so that we can see whether the qx has some roots possible or not from these given information. So suppose you want to substitute 1 there. So for x equals to 1 for the first integer value, that means the k is equal to x equals to 1. That q1 will give you that 2 into p1 minus 1. But what is p1 from this information for the pk? You notice that will become 1 over 2, and that is giving you 0. It simply means that I have q1 is equal to 0. It means x minus 1 must be a factor for this assumed polynomial qx. Now let's see what will happen at 2. So for q2, you can notice what will happen. That will become 2 plus 1, 3. And there is p2 minus 2, and so it is 3 times, and P2 from this information for the pk, again you can see it's a 2 by 3. They'll give you 2 by 3 minus 2, and so again it will give you 0. And so we notice that q of 2 is also 0. So what you can see, or you can assume for all these integers, that all the integers are solutions. To see this thing in one go, you can feel that k, for any x equals to k, qk means that here I'm writing this k, so k plus 1, and I'm writing pk minus k. Now notice the value pk is already given by the information in the question. They'll give you k by k plus 1 and minus k. It means it's 0. It means all these integers are the roots of this qx. And now you can understand why we are taking this qx in such. What we are doing actually mathematically, I'm just multiplying this thing this side. So it will become k plus 1 into pk. And I'm sending this k to the left. That will give you k plus 1 pk minus k. So it will give you 0. It means this whole thing I'm assuming is a qx, so that it will be consistent for every such integers starting from 1 to 2025. And all these integers will be providing the qk is 0. It means all those integers are solutions for this qx. So what I can, after this observation, what we can see that the qx must be a polynomial with x minus k roots, means with what we can say x minus k factors. What I mean to say that k is starting from 1 to 2025. But we don't know what will be the leading coefficient. So we say that, okay, qx is equal to some leading coefficient capital A, and with x minus 1, x minus 2, x minus 3, all the way up to x minus 2025. Now notice here one thing, that the px has the degree 2024 given in the question, but the qx has one extra degree, that because you can see that the number of factors are 2025. So the number of factors are 2025, well, of course the degree will be the 2025. Okay, so this qx I have, and the only barrier is to find out this a. Once we get this a, I can find the qx fully. I get the qx fully, and from here I will substitute the qx and find out the px. And of course this qx will be divided by x plus 1, so px will take the degree 2024, one less than the qx has. So how do we find this a? That's a challenge. So, but not actually a very big challenge, because you can see that this equation number 1, you can substitute x equals to minus 1 to kill this px directly, and we get the value of the q at -1, and we will use this to find out the a. Let's do that. So from 1, what I'm getting, from 1 I have q of -1 is going to be plus 1, because you're substituting here -1, and x is equal to -1, give this whole thing 0, and this will give you minus of -1, that is plus 1. Now again I'm substituting this information here in the second. So from 2 I can write q of -1, which is going to be 1 from the first, but again I'm using the right hand side of the second to substitute -1 at every place. It will give you a, and the first bracket will provide you minus 1, so that will be minus of 2. Again, negative 3, negative 4, and all the way up to negative 2026. So you notice how many brackets we had from the beginning is important. That is actually 1, 2, up to 2025. So there are 2025 brackets. From each bracket, I'm taking one negative sign common. So because the number of brackets are odd, so this will result in a negative sign in front here. That'll give you 1 and minus a, and that will give you 2 times, 3 times, 4 times, up to 2026. Now notice there's a 1 missing. So 1, when you write in the product or not, doesn't matter. There's already 1 there. So this whole thing from here to here, I can write as 2026 factorial. This is nothing but 2026 factorial. And so I got the value of a as negative 1 by 2026 factorial. This piece of information, I'm going to use it to define the QX fully. So what the QX will be now is, this QX is minus 1 divided by 2026 factorial into x minus 1, x minus 2, all the way up to x minus 2000. Now this QX again will be used to define the PX fully. What is our final goal? So PX is now, from the equation number 1, we can see is going to be what? You see here, this PX I can write QX plus X divided by X plus 1. So let me write it first. QX plus X divided by X plus 1. Now we can separate it. So it'll give you QX divided by X plus 1 and minus X divided by X plus 1. You notice that this must have a degree 2024. It is actually following because this thing you are dividing by X plus 1. So it will come as coefficient. I mean the degree is 2020. This is the PX here. And I have to evaluate the value of PX as 2026. So let's first write this value here. So 2026, here Q at 2026 divided by 2027 minus 2026 divided by 2027. Okay, now we find out the value of this QX at 2026. Let's find it out. Here I'm substituting Q at 2026. So they'll give you minus 1 by 2026 factorial. And here I have to substitute all the values starting from 2026. So the first, you can directly tell we don't have a space here, right? Write every bracket with 2026. So you can notice what will happen, that at x equals to 2026, that will give you 2025. This is 2024, and that will give you 1. So it is actually giving you 2025 in 2024 all the way up to 1. That is the product of all the natural numbers starting from 1 to 2025. So that is nothing but 2025 factorial. 2025 factorial. And so this will give you minus 1 by 2026. So this is Q of 2026 value. I'm going to substitute it here. And so it will produce minus of 2026 into 2027 and minus 2026. So here I think one mistake I've done. Here is a plus sign. I don't know why I written. Okay. So this is the value we got, and 26, and after that we have to evaluate it. So of course I will take this 1 by 2027 as a common, and what I get it here is 2026 squared minus 1 by 2020. Now notice that this I can write as a plus b, a minus b, two factors of it. So this I can write 2026 minus 1 into 2026 plus 1 and divided by 2000. So that will produce 2025 into 2027 and divide by 1000 into 2020. So of course this two cancels and we get the answer as 2025 by 2000. So this is the answer we have. All right. So this was the way to solve this question. There are other version of this question is also there, that we have to prove that this pk by k plus 1 is for any n. When n is odd, that will produce 1. When n is even, that will produce n by n plus. But anyway, there's one question I want to give you that I've already written, typed there. Question I'm referring here. The question is, if px, not px, is a polynomial is a polynomial of pd 2024, and this fx, not fk, is following this rule 1 by k for all k starting from 1 going all the way to 2025, then we have to find out f 2026. So how do you find it? It's not difficult because you know that what the rule. So only I can give you the hint, and the hint is fk by 1 by k is inviting us to follow the pattern and assume a new polynomial. So that polynomial I can assume is what? The hint. You notice I send this k this side, so I'll give you x into fx and take this one that side also, minus 1. And from there you see that all those integers will be the solution of this qx is equal to 0. And from there will build up the solution to find out the fx actually. And we, after all, we have to put the 2026 at the end. All right, that's it for today. See you in the next video with some other problem of such kind. Stay math active.